Hey there, quick intro video to 1.2.3, what can a rectangular array show? And we're really going to focus on characteristics of numbers, and characteristics are certain traits, if you will, about numbers. Mr. Crone has brown hair, so that's a characteristic of him. I'm a male, so that's another characteristic, right? So all of these are different things that kind of identify who you are. So make sure that you write the title into your notebook and put in the appropriate date for today, okay? So our quick review here is going to be on whole numbers, odd numbers, even numbers, prime numbers, and composite numbers, okay? So whole numbers, when you were just a little kid and you started to learn your numbers, right? You learned the numbers 1, 2, 3, 4, and you got super excited when you could get to 20, then to 100, right? Whole numbers are all of those numbers that you were counting when you were a little kid, and 0. Make sure you make 0 part of that whole numbers. Natural numbers are all the other numbers that you learned when you were growing up. Notice there's no fractions and no decimals in there. We've already talked about odd numbers. Odd numbers are ones that end in 1, 3, 5, 7, 9, end in 1, 3, 5, whoops, ... goes on, right? Forever and ever. Those are our odd numbers. All of our other numbers are even numbers. 2, 4, 6, 8, and then we would have 10. I could note that there is 0. 0 is an even number. 12, ... right? Now, we get into prime and composite numbers. Those are a little bit more tricky for us to know. When we think about numbers, we sometimes can take numbers and we can find out what numbers multiply to make that number. So, for example, the number 10 is 1 times 10, but it also has 2 times 5. So what we're doing is we're looking for those really, really special numbers where the only numbers that multiply to create that number is 1 and itself. So let me start by saying, let's start with a real simple one. 3. 3 is a prime number. The only numbers that go into 3 will be 1 times 3, right? Remember, we're showing multiplication as a dot now, right? So 3 is a prime number, right? So what about 4? Would 4 be that, right? 4 question mark? Well, of course we have 1 times 4, so that must be prime? No. 2 times 2 is also 4, so this one would not work. Would not work, so we got to get rid of that stuff, okay? So 4 doesn't work, and let's try our next one, 5. 5 works because it'd be 1 times 5, right? That's it. There's no other numbers that work for it. 7 would be another prime number. 9 is not. Whoops, battery's dying. 9 is not because of 3 times 3, right? 3 times 3. So here's a few other ones. 11, 13, 17, 19, and we could even choose some larger ones like 31. Would be one. I could put even some. I should put a ... in there because there's a lot of prime there's prime numbers between 19 and 31, and then there's some that go on forever, or go on past 31. Sorry about that. As a quick side note, there's an infinite amount of prime numbers in math. It's a really interesting thought. Infinite number. Okay, so we have also composite numbers. Well, right, composite numbers, if a number is not prime, it is composite. Oh, that's not very good definition, is it? It's not a very good definition when you use the word in there, right? But I think we could quickly figure out some of those numbers, right? 4 we had already said works because of 2 times 2, right? That makes it a composite number. 6 is also a composite number because of 2 times 3, right? 8 would work. 9 would work because of 3 times 3. 10 would work because of 2 times 5, right? 10, 11 does not. 11 is a prime number. 12 would work. 12 would work for a couple different reasons. It's 2 times 6 and it's 3 times 4, right? And we have all kinds of composite numbers, right? 27 is a composite number because of 3 times 9. 32 is a composite number because of 4 times 8, right? So there's a lot of composite numbers, and we also have a lot of prime numbers, but they can never be prime and composite at the same time, much like a number cannot be odd and even at the same time.